here we are. We're going to do questions 13 through 24, so multiple choice of geometry, June 2018. So I'm going to go all the way down to question number 13. That's where we're going to start. If you want to see the first 12, it's on the previous video. So I'm going to start right about here, I think. Yep. All right, beautiful. So the diagram below shows a parallelogram with diagonals AC and BD intersecting at E. What additional information is sufficient to prove that the parallelogram is a rhombus? So what do we need to know? Well, if it's a rhombus, the diagonals are not congruent. If it's a rhombus, the sides are congruent. The special thing about a rhombus is that the diagonals are perpendicular. So I didn't even look at my choices. Didn't even cover those up. So in my brain, I had that fact. So what additional information is sufficient? Well, BD bisects. Well, no, because that's not necessarily giving us that they're, oh, sorry. It's a rhombus. Okay, so then AB is parallel to CD. No, that's parallelogram. So no. AC is congruent to BD, not in a rhombus. AC is perpendicular, true. So you have to know those fun little facts about rhombi and squares and so forth. Oh, directed line segment has the endpoints -4, -2, and 1, 8. Point F divides DE such that DF to FE is 2 to 3. What are the coordinates of F? Depending on how you're taught to do this, I think most of you will use graph paper. What I did was this. I did the change in y over the change in x, also known as the slope. And I said, okay, I'm going to do, which way did I go? The y values are 8 minus -2. And then 8 matches with 1 minus -4. So that's 10 over 5, which is a slope of 2 over 1, right? Okay. So we have to go up 2 over 1 twice, right, for 2 segments. So up 2, right 1 twice would be up 4, right 2. So from D, D to F. D is -4, -2. So if I'm going up, that's the y's, and right is the x's. So I'm going up 4, right 2, which gives me -2, +2 for F. Okay, let me grab a piece of graph paper, and I think, hold on, let me. All right, so if you did this on your scrap graph paper, which I highly advise, you threw some axes in there somewhere over the rainbow. Oh, that's bad, right? So -4, -2 is D, so I can't, it's hard to see. 1, 2, 3, 4, -2 is D. And E is 1, 2, 3, 4, 5, 6, 7, 8. I might have to try counting that again. So 1, 2, 3, 4, 5, 6, 7. Okay. So this is F, right? Or D to E. We're looking for F. So if I go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 1, 2, 3, 4, 5, right? So again, that's up 2 over 1. So go up 2 over 1 once, up 2 over 1 twice. That will be F. Up 2 over 1, up 2 over 1, up 2 over 1 gives me the 3 after that. The coordinates of F are -2, 2. That's how I really would have done it, because I would like to use my graph paper. So -2, 2 is choice 2. Fabulous. Okay. 15. Oh, 15. Let me, oh, I hate how that gets stuck there. Sorry. Well, that was silly. I can't win right now. I'm not going to lie to you. I just can't win. All right, triangle Dan is graphed on the set of axes below. The vertices of Dan are these coordinates. What is the area of Dan? All right, so easiest way is to use this graph and let me go this. Capture him in a rectangle. All of the coordinates in a baby, well, it's actually not a baby rectangle. It's a big rectangle to capture that. Now, to find the area of all of this, I do the area of the square minus the area of each of the triangles. And that will give me the area of the whole big triangle. So, the big square, okay, or big rectangle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I just want to double check my counting. Yep. 11 by 12, so that's 11 by 12. Now, our first triangle here has a base of 3 and a height, what was that, 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and a height of 11. So that's 33, right, divided by 2. Triangle 1 is 33 divided by 2. Notice I'm not rounding anything yet. The second triangle is 1, 2, 3, 4, 5, 6, 7, 8, 9 by 1, 2, 3, 4, 5, 6, 7. Okay, so 9 times 7 is 63. But we've got to do half because it's a triangle. So notice, again, I'm not rounding or anything there. This one, we have a base of 12, and then we have a height of 4. 1, 2, 3, 4. Yep. Well, 12 times 4 is 48, divided by 2 is 24. So I'm going to go to my calculator, and I'm going to say the area of the rectangle minus the area of all of those triangles. So I'm going to clear this out. The rectangle was 11 times 12 minus, is there a minus button here? Oh, good. So minus one of the triangles, the first triangle was 33 over 2, minus the second triangle was 63, whoop, control divide, 63 over 2. Minus the third triangle was 24. And you get an area of 60. So let's go back here. Is that a choice? And that would be, oh, it is. It's choice 1. Yay! I always feel accomplished when I don't look at the choices and then I get the right answer. You should too. All right, now number 16. Oh, number 16. If you weren't paying attention, you did what I did at first. Here's the thing. Read the dang question, okay? Read the dang question. Don't think you know what's going on and pick an answer. Read the dang question and draw it. Okay, so triangle ABC has these vertices. Nobody cares yet. All right, which figure is formed when triangle ABC is rotated, wait for it, continuously around BC? So here's the trick. You are spinning around essentially this line, right? So you're going to go spinning around there. So if I were to do that, I actually am going to 1, 2, 3, 4, 2, 3, 4, 5. When I spin it around, it's going to look something like this. And this will be the circular side. This is my best attempt at a 3D picture. To draw these in AP Calculus all the time. But now here's the thing. The center of rotation is here. The definition of radius is from the center to the edge. The radius of this cone that's now on its side, right, looks like this. The radius of this cone is 5 units. So if you look down here, you can easily be tricked, okay? If the radius is 5 units, what's the diameter? Well, the diameter is 10 then. So you know it's not 1 or 2 because those are vertical, and we know it's sort of a horizontal. So this has a radius of 5 there, and this would have only a radius of 2.5. So it's got to be choice 3. Hopefully you didn't do that wrong, you know? All right, so this next one, and I'm trying to zoom in here a little bit. Oh, there we go. You have to know your circle facts, and I know there's like 100 circle facts. So there's really only a few formulas for angles in a circle. One is the central angle, so that's equal to the arc. On the circle is half the arc. Then it's the difference, and then if it's inside, then it's half the sum. So the formula you have to know is that this arc, okay, and this angle, well, we know vertical angles are congruent, so 58 goes here. That if you have angles inside, that the measure of the angle inside is equal to half the sum of the arcs. And I always just say it in words. I don't write stupid formulas. I just say what it is. So the measure of the angle inside is 58 degrees. And that is equal to half the sum of the intercepted arcs. Well, the arc that it's holding here is dB, and that's what it wants us to figure out, x, plus the other arc it's holding is over here, AC, which is 72. Okay? Now you have to think about what you know. You have a couple of options here. You can distribute the 1/2, which I think maybe a lot of you did, or you can get rid of it. So I'm going to distribute it because I think that's what you probably did. 58 equals 1/2 x plus half of 72 is 36. So we subtract the 36 over to the other side. What's 58 minus 36? What's that? 2? Okay, 22 equals 1/2 x. And then to get rid of a 1/2, you either divide by half or you multiply by 2. That means the same thing. So you get 44 is equal to the arc that we called x. That is choice 3. Now, again, you could do guess and check here. If you knew the formula, you could plug in, is 58 equal to 1/2 of 72 plus 108? No. Is it equal to 1/2 of 72 plus 65? No. Right? So you can guess and check here. There's very few questions you can check on this geometry test, and I would say, if you have that luxury, please do it. All right, so this question here, you may not have remembered this, and the way it was written was kind of tricky, so don't feel bad about yourself. In triangle SRK, medians SC, KE, and HL intersect at M. Which statement must be true? Here's what you need to know. The medians intersect and create a ratio of 2 to 1. Okay, 2 to 1. So this is twice this. Let's see, M to K is twice this. R to M is twice ML. So that's what you had to know. So if I'm doing that in my brain, I'm like, okay, so S to M is equal to 2 MCs. Is that a choice? No. M to K is equal to 2 MEs. and R to M is equal to 2MLs. And that's one of the choices. Like, you feel like it's going to be this one. It's not. SM and KM are not congruent. MC is 1/3 of SM. No. So what's this about? 3 MCs. So 3 of these equal everything from S to C. Oh, yeah, because there's 2 of them here. So 1, 2, 3 MCs equal the whole length of SC. So it has to be choice 1. That was tricky. Dirty, dirty trick. Okay. Okay, fine. Regular polygon rotated about its center. Which angle of rotation will carry it onto itself? Well, try to put a center in there to the best of your drawing abilities. Ish. Okay, so the exterior angle of rotation, right, 360 divided by 5 is equal to 72 degrees. So, here's the thing. One rotation of 72 is not a choice. So it's, well, we know it's not 60, so let's cross that out. 2 rotations of 72 degrees would map it onto itself, but 2 times 72 is 144. Not a choice. 3 rotations of 72 degrees is 216 degrees. Is that a choice? Oh, it is. There it is. That's all. Don't read too far into it. Equation of the graph below. Okay, I am actually going to show you something on the calculator, and I'm going to do this the real way, okay? So I'm going to do it the real way, and then I'm going to show you the fake way. You are going to love me for the fake way, so stay tuned for the fake way. Real way. We have a center of 1, 2, 3, 4, 5, 2. Yes? 5, 2. We have a radius of 1, 2, 3, 4. So a center of 5, 2, whoops, and a radius of 4. Your brain should tell you x minus 5 in parentheses squared plus y minus 2 in parentheses squared equals the radius squared. If r is 4, then r squared is 16. Yes? Multiply it all out. So x minus 5 squared means x minus 5 times x minus 5. And y minus 2 squared means y minus 2 times y minus 2 equals 16. So multiply this out, get x squared minus 5x minus 5x. Negative 5 times negative 5 is positive 25 plus y squared minus 2y minus 2y plus 4 still equals 16. All right, so x squared minus 10x. I'm going to hold on to him for a minute. Y squared minus 4y. And I have this 4 here. So on the left, I've got 25 and 4 is 29 total equals 16. So in all of these questions, they've really gotten that all alone. So x squared minus 10x plus y squared minus 4y plus 20. Oh, so I'm going to subtract the 29 over to the other side. 16 minus 29, sorry, my eye is twitching, is negative 13. So we do not have a plus 10x, so it's not choice 1 or choice 3. These two are the same, choices 3 and 4, except for what they're equal to at the end. And so it has to be choice 2. Okay? Now, wait for it. A couple of other things you could have done. Plug in this point. See if it makes the equation true. What is that? So this is 5, 2. So this is 6, 7, 8, 9, 2 would make the equation true. So you plug in for x and y, or you store for x and y and see that it's true. I'll show you that way real quick. 9, control, I say fast. I'm going to do this fast, but control store. Oh, escape. What did I say y was? 2, 2, control store for y. And then you can just type it in. X squared minus 10x plus y squared, minus 4y equals negative 13, right? Holy smokes, that worked. So you could go through the choices like that and see which one was true. Your other option is this. If you go to your graph, and, oh, I should clear that out. Sorry, doc B. Anytime you store anything, clear it out afterwards. If you go to your graph and you do menu, entry edit, and you go down to relation. I guess you could have deleted the equal sign too. And you graph the one we just said, minus, the one we said worked. Oh my word, 10x plus y squared minus 4y equals negative 13. It will graph this for you over here. I like to delete the equation. I don't like to see it. And you can find the center. Well, first of all, 1, 2, 3, 4, 5, you can count the center here. But if you go to, if it's like a weird one, if you go to analyze, down at the bottom it says analyze conics, meaning conic sections. So center of a circle. You click on it, it will tell you 5, 2. So you could do that with all of the choices, which is awesome. So again, this is something that you could have used your calculator for, and you could possibly get right by just kind of fiddling around. So use your calculator when you can. Again, there's not a lot of times in geometry that you can do that. So use it to your advantage. Okay, so number 21. What do we got going on here? Oh, the silly mid-segment again, right? This is the third time we've seen it. Oh, my eye is twitching. I don't know if that means I haven't had enough coffee or too much coffee. What is the length of QR? So they give you all this information. All right, let's mark our diagram. ST is parallel to PR. Fine. PS is 2, labeled. SQ is 5, labeled. TR is 5, labeled. We want to know Q to R, this whole length. Okay, so I'm going to call this X. Let's see, so what do we know? Well, we know that this whole side is 7, right? And we want to know this whole side eventually, but we're going to find X first. You could also do this a different way. So this whole side is X plus 5. I guess can't really do it a different way. So big triangle, 7, matches with small triangle, 5, equals big triangle, side is X plus 5, over small triangle is X. Cross multiply, that should be your favorite thing to do in math ever. So 5 times X plus 5. Please write that. I know it seems silly, but sometimes you do the silliest things, and it's so frustrating. So 5x plus 25 if we distribute. Subtract the 5x over. So x is equal to 25 over 2, which is 12.5. Freeze. Do not circle that answer. Do not circle that answer. Always go back. Q to R is what they're looking for. So it's x plus 5. Add 5 to that, and you get 17.5 or 17.5. I know. Probably the most missed would be picking choice 3. I'm aware. All right, so circle. Oh, yay, circles. The diagram below shows circle O with radii OA and OB. The measure of angle AOB is 120, and the length of the radius is 6 inches, which expression represents the length of the arc in inches. So if you look at your choices, you can tell that they're all in radians, true? Which means you better change that 120 to radians immediately. 2 things you need to know, changing to radians. So you take the angle and you multiply by pi over 180. Depending on how your teacher does it, they might have you do a proportion or something. It's fine. So 120 pi over 180. Did I write anything else? No, I didn't. Okay, so that's our angle in radians. I didn't even reduce it. You could do like 12 pi over 180, or you could reduce that fraction, or 12 pi over 18, sorry. Or you could reduce that fraction further. I didn't. You have to also know that the arc length formula is the length of the arc is equal to theta. It's really the absolute value of theta times the radius. Well, the arc length is what we're looking for. Theta must be in radians. That's a big deal. They like to trick you. So theta is 12 pi over 18 times a radius of 6. Now I'm looking at all these choices here, and I think you can see it too. They have pi's in them. First of all, you know it's not choice 2 because they're trying to mess with me there. Where's my pen? It's not that one. So if I go to my calculator again, I'm going to type everything that I have on my paper except for the pi. So control divide, 12 over 18 times 6 is 4. But I didn't type in the pi, so it's 4 pi. So equals 4 pi. Is that a choice? No. Well, what the heck? Okay, so you have to see which of these is equivalent. Well, in my brain, I'm looking at these two. 36 divided by 3 is 12, so that would be 12 pi. I'm looking at this one. 12 divided by 3 is 4, so that would be 4 pi. There's our answer. You could also go to your calculator to see which one matches. Nothing crazy. Just trying to teach you some other things about fractions and numbers as we move. All right, so number 23, we're closing in on the end here of the multiple choice. Good. So typically towards the end, the questions do get more difficult. I'm not sure that happened here, to be honest, for once in my life. Usually 24 is like the hardest question. So line segment CD is the altitude drawn to hypotenuse EF in right triangle ECF. EC is 10, EF is 24, then to the nearest 10th ED is what? Okay. This is a pretty basic similarity question, and so you want to be careful when you're drawing your picture. Line segment CD is the altitude drawn to the hypotenuse EF in a right triangle. Hypotenuse EF. So that means this is a right triangle. Yeah? Okay. E to F is 24. E to C is 10. If they give me anything else. We are finding ED. Redraw your triangles. Redraw your triangles. Redraw your stinking triangles. So you should have a baby triangle. And my baby triangle is, let's see, D, C, E. And E to D is X, and C to D is 10. My middle triangle, like my mama triangle, right? Baby bear, mama bear, papa bear. Angle, right angle is D. And let's see here. Oh, am I losing my mind here? So D is my right angle. C will be here, right? C will match here, and then F will be here, because the hypotenuse is CF. Beautiful. And then C to D is 10. My big triangle, hopefully I don't need this room down here, well, has a right angle at C. E will match with E. F will match with F. There we go. Right angle here. And E to F is 24. And we are looking for E to D. Yeah? Okay. What do we have? What can we do? So we can see, oh, did I label that wrong? E to C, no wonder. No wonder. E to C is 10. How did I do that? E to C is 10. E to C is 10. There we, now, sorry. That was, I don't know what my problem was. Okay, so I'm going to use a blue. All right, so basically this triangle is useless. Fabulous. So now you can see that you have two similar triangles, and you can see their side ratios set up real nicely. So in the little triangle, I have a hypotenuse of 10. In the big triangle, I have a hypotenuse of 24. In the little triangle, I have a leg of x, and in the other triangle, I have a leg of 10. So you're going to cross multiply. 24x is equal to 100 divided by 24. And what do we get? We know it's 4.2, I believe. So it'd be choice 1. Sorry that I did that wrong. That was weird. I just labeled wrong. 24, this last question here, is actually easy if you know the one fact. So line MN is dilated by a scale factor of 2, centered at the point 0.6. If MN is represented by negative 3x plus 6, which equation can represent M prime, N prime, the image of MN? So I'm again going to go to that graph paper. Whoa, that was real jumpy. Negative 3x plus 6. Wonder if I can use the same graph paper. So y equals negative 3x plus 6, and they're saying the 0.06. Okay. That means a y-intercept of 6, 3, 4, 5, 6, and a slope of negative 3. Down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1, up 3 over 1. And now, you guys, oh my gosh, I am so sorry about this line. Yeah, no, this is not great. Okay, let's just pretend it's good. All right, so it says that, let me go back. Dilated by a scale factor of 2, centered at the point 0.6. Zero 6 is on the line. So if you are dilating a line by a point on the line, then it is the same line. It does nothing. So dilating a line through a point on the line is the same line. That's a fact you have to know. So dilating a line through a point on the line is the same line. So if you know that fun fact, then you go, oh, it's right here. That's it. It's over. Okie dokie. So that is the multiple choice. If you want to see the open response, go on to the next video.